In this video lesson, we are going to look at surds with variables. In our first example, we have the following. Now, these are two brackets containing binomials, and normally what we do to simplify it is we'll FOIL it out. Although, we can see that these two brackets are identical except one is a plus and one is a minus. So instead of multiplying it out, a faster way would be to remember that difference of squares, if I have difference of squares, it factors like x plus y and x minus y. Identical brackets, one is a plus, one is a minus. So that's in the same form as difference of squares, which means I can just take it back to the original form. And in that case, I'm going to take the first term and square it, write a minus, take the second term and square it. So 8x, we square it, and then minus the second term 12x and square it. Okay, so exactly as it is, we just write it and square it. Okay, so if I this root and the square will cancel, so we got 8x minus 12x, same happens here, and then simplify. 8 minus 12 is negative 4x. Then for example 2, so first of all, I'm going to just prime factorize. 64 is 2 to the power of 6, then x to the power of 6. And this is in a cube root, minus the fourth root. 81 is 3 to the power of 4, x to the power of 8. And 25 is 5 squared, x to the power of 4. Okay. Then what we do is when I have, let's say I've got x to the power of 6 in the cube root. When you take the root, you've got an exponent, you've got a power of a root. So you take the exponent and you divide it by the root's power. Okay, and then that's just x squared. Okay, so the base of 2 can come out. That becomes 2 to the power of, actually 2 to the power of 2, because 6 divided by 3 is 2, and then x to the power of 2. And here, we have just 3 because 4 divided by 4 is 1 and 8 divided by 4 is 2, plus then 5 squared, square root of 5 squared is just 5, because 2 divided by 2, there's imaginary 2 there. 2 divided by 2 is 1, and then x, this is why we halve the exponent whenever we take a base out of the square root. So this is then 2. Alright, now we have like terms. 2 minus 3 is, oh, actually this must simplify first. This is 4. This is 4x squared minus 3x squared plus 5x squared. Okay, so 4 minus 3 is 1 plus 5 is 6. 6x squared. Right, then the final one. So again, I'm just going to start by prime factorizing the ones in the roots. But notice that 8 is 2 to the power of 3. But if I have an even root, then I normally write it like this. I would divide I would separate 2 squared times by 2. So I'd write the highest even number times by the next base, times by that base to the power of 1, just to give it an even. And then, because what happens if you take it out of an even root, then it's much clearer to see, okay, I take this out and then this is left. Okay, so we'll see how that applies now. So that's just the same, minus 2. This is 2 squared times 2 x to the power of 8 over, again, 2 squared times 2 x to the power of 8. Okay, then we can start by taking the root. So this x, I'm just going to put it on this side, because normally we put our constants on the before the variables. So when I take the variable out, I'm going to put it on the right hand side of my root. So it's going to be 6 square root of 2 x to the power of 4, it halves, minus 2 times by 2. This is the 2 that came out here, and then there's a 2 left, and then the x comes out as x to the power of 4 over 2 comes out, 2 is left, x to the power of 4. Alright, then simplifying that further, 6 square root of 2 x to the power of 4 minus 4 square root of 2 x to the power of 4 over 2 square root of 2 x to the power 4. Okay, now I'm going to treat this as the variable, this whole thing. I'm going to treat this as the variable. If one was a 2 and one was a 3, we wouldn't have been able to do that. But now because they're identical, we can just look at it as maybe 6y minus 4y and get 2y. So instead of y, we now have square root of 2x. Okay, so this is going to be 2 square root of 2 x to the power 4, and that's also over 2 square root of 2 x to the power 4. These guys cancel with each other, and you're left with 1.